Today, we'll talk about domain and range of rational functions. From the word rational, it means ratio is involved, which is something over something, like a fraction. Yes. So when we have a fraction, domain means the inputs, the values of x that will make the rule to work. That's our rule. Now, we don't want the under to be equal to 0. So everything that will make the under 0, we remove it. So I can go ahead and say my domain, dom f, is equal to all the numbers will work. Every number will work except one number. The number that will make the under 0. The value of x that will make the under 0 is it 5? 5 minus 3 is not 0. Is it 4? It's not 4. Sum. Yes, correct. 3. 3 minus 3 is 0. Therefore, s is not allowed to be 3. So we'll say domain is all real numbers except 3. Everything will work except 3, because 3 as x makes the under 0. Yeah, like you can look at here now. If I have 5 divided by 0, a number divided by 0, check it out yourself. Punch your calculators and check. You will see that a number over 0 will give you math error. Math error. It's undefined. A number over 0 will not work. Yes. That's why we have to make sure the under is not 0. Everything, this thing means every number will work except the number that will make the under 0. That's our domain. Numbers that will make the function to work. Alright, so quickly, let's find the range. The range Rf is equal to all real numbers. Here is where you have a confusion. Most persons will tell you the range is all real numbers. No, but the actual range is all real numbers except 2. All real numbers except 2. You can ask me how. Where is the 2 coming from? I know you'll be wondering where the 2 is coming from. I will tell you. Now, how we'll call asymptote? Yes, asymptote is just like a line tangential to a curve at infinity. Yes. So how we'll call the HA, the VA, and the OA. Horizontal asymptotes, vertical asymptotes, oblique asymptotes. Oblique can be called slant asymptotes. Now, these two you are seeing here is coming from the horizontal asymptote of this function. Yes. Now, if you want to know how, see what you will do. You can say let y be equal to your f of x, which is 2x over x minus 3. After doing this, you go ahead and make s your subject formula. Make s your subject formula. When you're done doing that, I mean you try it out. I am showing you how the two came about. When you're done doing that, you must have an answer that has y minus 2 under here. When you now find the domain of x, dom x becomes your range of y. So with that, you will now see 2. So this method is long and confusing if you're not skilled enough in algebra. That's why I employ the idea of horizontal asymptotes to tackle this problem. So quickly, I will show you. Just that you will not have the full understanding because we have not treated limits that tends to infinity. But just flow with me. This function is saying 2x all over x minus 3. Yeah. Now I want you to check degree of my numerator. Degree of numerator is the highest power of x. Your numerator, the highest power of x. And that's 1. Under is also 1. If I have this now, let me say I have a fraction, yes, 2x cubed plus 5x squared plus 10 all over 4x squared plus 7x cubed plus 5 as a function g of x. In this one now, yes, is a function, yes, a fractional function, that's a rational function. In this one now, if I ask you degree of my numerator, that is, I am asking you to tell me the highest power. Degree of numerator means the highest power of x in the numerator, and that is 3. Also, if I ask you the degree of my denominator, that means I'm asking you the highest power of x down, and that is also 3. Yes. Now in this case, I won't explain in deep until we treat limits. Just for now, believe by faith. In this case, by HA, to find range, all you need is your horizontal asymptote. Whenever your degree up and down is equal, your HA is equal to those leading coefficients. Those coefficients of your highest power. Here is 2, for here it is 7. So my HA becomes 2 over 7. Therefore, my range of this function is going to be all real numbers except 2 over 7. Once you find your HA, your range is all real numbers except the HA. That point you have your asymptote for horizontal. Yes. So what if my degree here is 2? Don't see here is 3, here is 3, and here is 5. What happens? You will now see that degree of the one down is bigger than degree of the one on top. Yes, down highest power becomes 5, up becomes 3. They are no longer equal. When the one down is bigger, your HA becomes 0. When degree of the one down is bigger, your HA becomes 0. Take notes. So here, in a case like this, my range becomes all real numbers except 0. That's my range. HA, you check your degree for numerator. you check your degree for denominator, you compare them. If down is bigger, your HA is 0. If they are equal, you check the leading coefficient. It's not yet complete. Based on law of trichotomy, yes. So we have to also check what if the one on top has a bigger degree. For instance, let's say here is 7 and here is 5, the way it is. You see, in this case, the one on top is bigger. Whenever the one on top is bigger, it means that you will not have a HA. You won't have a horizontal asymptote. You have an oblique asymptote. When the one on top is bigger, when the one on top is bigger, there is no HA. You have a slant asymptote. With this, you can now say that the range of this function is all real numbers. We don't exempt anything because there is no HA. The only time you exempt is if we have a horizontal asymptote. So far I've given you the 3 conditions, and I'm saying that when the degrees are equal, the leading coefficient becomes your HA. When down is bigger, the HA is equal to 0. When up is bigger, there is no HA at all. We have an oblique asymptote. When we learn asymptote in full as a topic, you have more understanding on this. Also, when we treat limits at infinity for rational functions, you will get more knowledge on this. For now, just believe by faith. Let's forge ahead. So I am saying that domain here is where the function will work, and that is it will work everywhere except 3. My range is all real numbers except my HA. And HA here is, if you check, here is 1 and here is 1. So 2 is here is 1 invisible. 2 over 1 is 2. How I got 2. Yeah. So actually, you can still write this thing on interval notation, and that will be dom F is equal to minus infinity. We remove 3 from the real line down to 3, yes, union 3 down to infinity. That's our domain. And our range RF is going to be minus infinity down to 2, union 2 down to infinity. So any of this you see in your option, if it's OBJ, that is your answer. I hope it's clear. Let's take more examples. Let's solve for g of x. So dom G, domain of G will be all real numbers except what? What will make the under 0? I think here, when s is 2, here becomes 0. And when s is 7, 7 minus 7 makes here 0. So we will not allow x to be 2. We won't allow x to be 7. So all real numbers except 2 and 7. Yeah. We can also place this thing on interval notation to be minus infinity down to 2, union 2 down to 7, union 7 down to infinity. Check our video on interval notation to understand this. So my range of G, R sub G, will be, if you check, when I expand these two terms, x is here, x is here. When I expand this, I will certainly have x squared. Yeah, certainly when you multiply 2 terms having x like this, you must have what? X squared as your first term. So with that, I can know the degree of my x in my denominator. So my degree, when I have x squared as my leading coefficient, I will have it as what? 1 invisible. Hope you're following. You know, if I ask you what is my degree on top, it's clear, it's 2, power 2. So 1 is here. Also, when I expand this, I will have 1 somewhere around the x squared. That makes my HA. My HA is now going to be, based on what I said earlier, it will become 1 over 1 because they are equal in degree. When degrees are equal, you just take their coefficients. That will be 1 over 1, which is what? 1. So my HA is what? 1. With this, I can now say that my range is all real numbers except my HA, which is 1. I can also write it on interval notation, and that will be minus infinity. Let's go and remove 1, down to 1, union 1, down to infinity. That's it. Quickly, you have solved it. Domain, range. Let's solve question 3, can we? Yes, we can. Now, dom f, the function is defined on f. So we have dom f. Dom f will be, normally, fraction is always all real numbers except what will make the under 0. Here, I think is 1. You know, if this place becomes 0, no matter what here and here is, they all becomes 0. That's why we don't allow x anywhere to be 0. Yeah, so we don't allow x to be here 1, here 2. 2 here will make this place entirely to be 0. 2 minus 2. Here 4 minus 4. So x will be allowed to be 1, 2, or 4. 1, 2, 4. That's my domain. Yeah. And on interval notation, I know you can remove them from the real line. So I don't have time for that. So my range, or let's do it, that will be minus infinity minus my domain, dom f is equal to, let's do it, that will be minus infinity, down to 1. You'll see 1 first. As you're going, you see 1 first. So you remove 1, you continue, start from 1, you move down to 2. Remove 2, you continue, from 2 down to 4. Yes. You don't stop there, you continue, union from 4 down to infinity. Hope you can see that. 4 down to infinity. That's it. Now, the main thing is the range. The range is where you employ the idea of asymptotes. Yes. So my range, RF, will be my asymptotes. When I expand this, certainly 3 brackets having x, x, x. When I expand, I must have x to the power of 3. Yes. Therefore, my degree for the one down is degree 3. Up is degree 2. Which one is bigger? Down. Therefore, my HA here, my HA is going to be 0 because degree of the one down is bigger. When down is bigger, is 0. When up is bigger, there is no HA at all. We have oblique asymptotes. So with this, I can now say that my range is all real numbers except 0. This thing means there is no answer you can get from this function that will give you 0. There's no input that will go in as x and the answer becomes 0. We can never have 0 from our answer. Yes. Now, let's take one more example. Alright, then we call it a day. So, our last example says if f of x is equal to 2x squared upon x squared plus 1, find the domain and range. Solution to this. Our domain for every fraction, every rational function will be d sub f equal to all real numbers except what makes the under 0. Look at this. Look at this. What makes the under 0? Nothing. Nothing will make the under 0. Reason because any negative number that goes in as x, when we square it, it becomes positive. So all the numbers grows large except 0 itself. 0 squared will give us 0. Assuming it's like this, only x squared, then we can have the under as 0. But since we have plus 1, this plus 1 here, we will never allow the under to be 0. When you have x squared plus something, it can never be 0. If you have x squared minus something, yes, you can have 0. But x squared plus something positive plus something, you can never have 0. That means our domain is all real numbers, apart from nothing, just all real numbers. That's our domain. Then our range. Let's look into range, RF. Our range will be, the bottom here, the outcome, the image here, the output from this place will always be positive. Yes. And also, if you check on top, you will see that the outcome also on top is x squared, always positive. Therefore, this function can never be negative. Yes, it can never be negative. Therefore, my range will be all positive real numbers. But also, if you check this function, we will have our HA, that is horizontal asymptote, to be 2. That's 2 over 1. Because the degrees are equal degree. Therefore, I will have it that my range will start from 0, because when x is 0, I can have 0 as my output. If x is 0, I'll have 2 times 0 squared, which is 0. 0 over all these things gives us 0. So 0 is included in our output. So I'll include 0 using a closed brackets. So from 0 down to, I'll have to remove my HA, which is 2. So I will move down to 2, I will remove it. Union, start from 2 and move down to infinity. This is the range of this function. Sam, I hope you learned something from this class. If yes, click the like button. Also, subscribe and stay tuned for more videos. Once more, this is Learn Extra and I am Holgate Emmanuel. Thank you.